I'm Joseph Fisher, project manager from Up and Over Consulting. Our company was hired by Sandag and the City of San Diego to prepare a feasibility study on implementing a new sustainable aerial cableway in downtown San Diego. Aerial cableway technology is being utilized successfully throughout the globe as an alternate source of transportation. Over the last decade, the City of San Diego has shown a great interest in becoming a sustainable, smart leader in green transportation technology. Let me walk you through our feasibility study. The Up and Over Consulting team is comprised of myself, Joseph Fisher, project manager, Jessica Gutierrez, transportation, Ryan Murphy, structural and geotechnical, Chris Shaver, construction and cost estimation, Aaron Weintraub, environmental and CAD design. The purpose of this project is to determine the feasibility of an aerial skyway in downtown San Diego. This alignment would run about 3.7 miles along Harbor Drive from Terminal 2 of the San Diego International Airport to the Gaslamp station in downtown. As you can see here, the proposed stations would be built on city-owned land at Terminal 2 of the San Diego International Airport, with a stop in Seaport Village, and finally ending at the Gaslamp.
The transportation study was conducted in order to calculate the potential annual Skyway ridership. We used a 2015 MTS traffic study along North Harbor Drive, airport arrival and departure rates, and events such as Comic-Con or Padres games to calculate an expected range of 1.5 to 1.8 million riders per year. This is summarized in the table shown below. The travel time was calculated based on Doppelmayer's D-line, which runs at a constant rate of 16 miles per hour. Each gondola would be able to accommodate 8 passengers and their luggage. Racks can also be fitted to the outside of the gondola to hold bikes.
In support of the Harbor Drive Skyway feasibility report, we conducted a preliminary geotechnical study of the area along Harbor Drive. According to the City of San Diego Seismic Safety Study of Geologic Hazards and Faults Maps, the proposed alignment route lies in close proximity to the Rose Canyon Fault Zone. Based off our analysis of several soils reports that were conducted recently in support of construction along Harbor Drive, we found that the alignment route is potentially sitting on fairly poor soil conditions. From data analyzed from borings drilled by Nino and Moore, it was determined that the area along the route has potentially unsuitable artificial fill at depths of up to 20 feet, which can be seen graphically in the geological cross-section figure. The poor soil conditions in the area and potentially large lateral loads applied to the tower structure, which required a minimum embedment depth of 26 feet, means that typical tower foundations for this section of the alignment will be 6 feet in diameter and 50-foot deep drilled piers with 12 number 9 bars for vertical reinforcement. The specifications should be patterned after recommendations included in the standards and specifications for the drilled shaft industry. To minimize the impact on the existing environment, our team is proposing tower locations along the existing right-of-way to avoid land use issues. To facilitate this, we designed L-shaped cantilever towers, which would stand along the right-of-way and span 30 feet to the center of Harbor Drive. Due to a minimum clearance from obstructions of 25 feet per the City of San Diego, the max height of the tower would be 80 feet. The beam, spanning 30 feet over Harbor Drive, was designed as a structural steel wide flange section 27 inches deep. This, in turn, is fixed to a square, hollow structural steel section that is 24 inches in cross-sectional area. The column itself would be built up of several smaller sections and would be mechanically fixed to the foundation by means of a 4.5-inch thick steel base plate with a full penetration fillet weld. The cable pulling the carriers would be made of A500 grade B46 steel or better and would be a continuous woven steel rope with a minimum 1.5-inch diameter. The design itself is preliminary and was conducted solely in support of construction costs. Moving forward, a much more dynamic analysis analyzing the system as a whole with moving point loads would be required per the national standards on aerial passenger ropeways in the 2016 California Building Code.
Through the analysis provided in the environmental impact report, it was determined that overall this project does not have the potential to generate significant environmental impacts. With a goal for creating a cleaner San Diego for future generations, the City of San Diego's Climate Action Plan calls for eliminating half of all greenhouse gas emissions in the city. With the proposed Skyway, a reduction in greenhouse gas emissions can be expected due to a reduction of cars on the road. 3,300 metric tons of reduction in greenhouse gas emissions can be expected from the Skyway. This amount of greenhouse gas emissions is equivalent to that of produced by 66,000 homes. Footprint impacts will also be kept to a minimum with a max of 6-foot diameter towers and 120 by 60-foot stations, which will all be located in the existing public right-of-way. The main environmental concern will be visual impacts along North Harbor Drive near the waterfront park. These visual impacts will be kept to a minimum by ensuring the lowest safe tower height is used. Overall, this project is directly in line with San Diego's Climate Action Plan and will lead us towards a more environmentally friendly city. A few constraints will need to be taken into account for this project due to its unique nature and location. The major constraint is the alignment's proximity to the airport. Due to the location, this project will require FAA approval. As shown in the FAA risk map, the alignment crosses through a high-risk zone. A next constraint will be trolley power line crossings, which will need careful consideration during design and possible MTS approval before the project can move forward. There are many other constraints to be taken into account, but these are two major ones that could stop this type of project.
In compliance with the feasibility study, we have analyzed the implementation costs of the proposed aerial cableway. A capital cost estimate has been prepared for the project, and this estimate shows the overall construction and design cost to be $112.5 million, approximately $30 million per mile. In comparison, the implementation cost of a light or heavy rail system ranges from $100 million to $200 million per mile, which is a drastic jump. Below you see a summary of the itemized cost estimate. It is broken down into 6 major components, which consist of the aerial cableway and elements, station and infrastructure, site work, systems, professional services, and unallocated contingencies. In order to show the financial benefit of the Skyway, we have projected a potential annual revenue based on local public transportation fare rates and estimated annual ridership. This projection is shown with 2 possible fare rates of $2.50 and $5, along with a low and high ridership estimation of 1.2 million and 1.7 million. At the low fare rate of $2.50 and a high annual ridership of 1.7 million, the potential annual revenue from the Skyway would be approximately $4.25 million for the city of San Diego.
In conclusion, the Up and Over Consultants team has found that the proposed Skyway in downtown San Diego would be feasible due to its low implementation cost, potential high ridership, and low environmental impact. We think implementation of the Skyway will further define San Diego as a leader in sustainability. Thanks for watching and have a great day.